So after you log into the PBX as administrator, the PBX takes you to a page that shows on a page a lot of graphs, and I wanted to explain to you in this video what it all means and how you can read those graphs. So first of all, this is the screen that shows the graph of the whole system. We have stripped down versions of those graphs inside every tenant, and even sometimes inside of an extension. But on this in this video, I'm just going to show you what it means on the system level. First of all, on every page on the top, we include a kind of snapshot graph, which you can see on the bottom, top right. You can see here the calls overview of the system, which is obviously a pretty important number. And on the next to it is the registration graph, so we can see how many registrations are active on the system, and that's always helping you wherever you are to see if there's anything really getting out of control. So when you log in, we first of all show you the call graph, which consists of two components. One is the actual number of calls as the user would perceive it. So a call can actually contain of just a single call leg or multiple call legs. If one person calls another person, we usually have two call legs, because the first one calls into the PBX and then the PBX calls out of the PBX to the other party. Why is the call legs important? Because from a technical point of view, that's the resource which is being used. For example, if you have calls with many parties, like in a group in a page, when you're paging many extensions, that costs a lot more resources than just a basic call. That's why we show both numbers, the number of calls and the number of call legs. The next one is the call quality, because obviously we want to make sure that the calls sound good, and we're using something called mean opinion score, MOS, for that, which is a number between 1 and 5. 1 means it's very bad, essentially means smoke signals, you can barely hear anything. And 5 means that we have like CD quality, like absolutely crystal clear audio. And yeah, we're showing that over the past 24 hours. So you see here, like on the left side is actually 24 hours ago, and on the right side it means the current time here, the one. Okay, maybe you can see that with the mouse. So on this graph you can see it's like a cloud. The darker the cloud means the more calls in that area. And in this graph we obviously have a lot of calls. They're quite okay, and usually G711 is like 4.1. So and depending on the round trip times and delays and packet losses, the numbers go down a little bit. So we have some more calls which are lower, and they might be because they're using a bad codec or have a long round trip time. And it's actually not really ideal what you see here. I mean, many calls are okay, but on the other hand, many calls are not really okay, because the quality really goes down to like a level. This is like 2.5, which is, yeah, something where essentially you want to do something about it, either by changing the codec or checking if the packet loss is too high or maybe the delay is too high. Then we have another graph here for registrations. So we keep track of the number of registrations as in a device registers to the PBX, and that's interesting from the point of view how many, for example, VoIP phones are registered at a time. And we also show, like with the calls graph, we show you the number of registration plus subscriptions, because from a resource point of view, the subscriptions are also significant. It's quite normal that there are a lot more subscriptions than just registrations, especially if you're using BLF, because every BLF button is a subscription. And so this is also giving you an overview on how the system is doing there. If there are dramatic changes, that's obviously not good, because that means maybe like a branch office went offline, or if it really drops to 0, that means the whole server went obviously offline. And because this is so important, we have a special graph for the registration changes, where you can see how many changes were happening doing, or actually you just saw that it just refreshed. So every 6 minutes we're refreshing that graph. So anyway, so we can see the changes over the time. And in this case, you see like approximately every, you can hover over it, right? Every 30 minutes there was obviously like a registration change. And that's quite normal. Sometimes we have, for example, users behind a buggy router that disconnects every hour, TCP connection, and then that device would have to reconnect. So it's not ideal what you see here, but it's on the other hand something which is quite normal in the VoIP world, that registrations are coming and going. What you do not want to see is like a huge spike up and down, because that usually means that like a bigger group of users is going offline. And you see we have here approximately like 60, 70 registrations on that system, and then like one going on and off. It's something that is not ideal, obviously, but it's close to ideal. It's not too bad. Nothing that I would really worry about. Then another important graph is the media CPU usage. This is a critical resource for the PBX. So we have two numbers here. It's the peak CPU usage and the average load in that time interval. And you can see barely anything here. I mean, we had like maybe 6 or 7 calls. So it's not really moving the needle. It's like 1 or 2% of the CPU. That means our system is totally underwhelmed from the call load. But it's a very important graph, because you want to make sure you're staying somewhere below, let's say 75%, because otherwise you're ending up in a lot of jitter for that system. And we don't want that, because we want good quality for our users. And the memory is another important graph, because we're doing a system that's supposed to run 24/7, and we want to make sure we're not running out of memory. That's why we're monitoring like the memory usage over time. And so this system is using essentially 1.5 gigabytes of memory. That's not too bad, and it's kind of staying there. This is what we want to see. Then we're monitoring the port traffic. So here you can see over the past 24 hours how many requests came in over HTTP. We still see a couple of requests coming in, like 17 or 20. This is like per second. And during the day it went up a little bit to maximum like 150 requests per second. It's not unusual, especially when the browser is being used. The browsers keep requesting pages in bursts, so that number can be very spiky. But it's not looking like anything like denial of service, where the numbers can go into the 100,000s per second. So this is still very much okay. And we're also watching how many SIP packets we're receiving per second. And so we differentiate between different transport layers: SIP UDP, TCP, and TLS. And here in this example, you can still see, like, okay, it went up to 587. That's okay. I mean, as I said, it can also be like in the 10,000 per second would be still like okay. You just want to be aware if there's anything going on, like anybody bombarding the PBX with SIP packets, so that the session border controller would kick in and kind of slow it down. We do have TFTP and FTP ports, and there should be actually nothing going on, and that's a good thing, because the ports are closed anyway. So especially FTP ports, if you have an FTP port publicly open, you would see probably all the robots finding that port and trying to guess default passwords. So it's just another reason not to even open the port and stay away from that trouble. And we're also monitoring the LDAP traffic, which is usually done by the VoIP phones. When you do an address book search, they go there and requesting LDAP. Obviously, nobody is using LDAP-S, so everything is insecure. Well, that's because most of the phones are not really able to do secure LDAP still up to date. And another, last not least, important graph is not the CSTA. I mean, we're monitoring CSTA as well, but this is really only interesting if you are using CSTA. In this system, that's not the case, so that's a 0 everywhere, but we're monitoring the TCP SYN. That means every time that where a TCP port is being opened, we're counting that. And that is a critical number because especially with the distributed denial of service, those numbers can get really high. And because of the design of the operating systems, the process has to process every single TCP SYN request and check if it was valid or not. And that's why we want to keep an eye on it and make sure that that number is not getting too high. And yeah, so this graph is actually sent every 24 hours to the system administrator, so you have it on file. And I would recommend to archive those emails so you can kind of go back in time. Also, what we have done in version 68 is that we're saving the graph information, at least on a system level, so that after a restart you don't lose those graphs anymore like it used to be in the older versions. So it would continuously show what happened last 24 hours so that you are aware about the health status of your system.